Okay, let's resume last time's lecture. So last time we actually talked about hierarchical clustering, and it's a bottom-up clustering algorithm. The general idea is that it's common to all the clustering algorithm is that you actually start with every object in its own clusters. So in this small example, we have we have five clusters initially, and the general idea is that we keep on merging two clusters into a larger one, therefore reducing the number of clusters by one. So if you keep doing this, at the end of the day, you actually end up with only one cluster. Now, what's the criteria to choose which two to merge at each step? So intuitively, we should choose the two which are most similar to each other. So if we use a similarity measure, basically the most similar to cluster should be the similarity of, let's say, Ci and Cj is the maximum. Okay, the maximum. And alternatively, we can use a distance or dissimilarity measure. Then the most similar pair of clusters is the case where their distance is actually the smallest, which is the minimum. Okay, so this is always uh, always chosen in each and every step. Okay, so there is no other choice. Like we should never intuitively never merge two clusters which are totally different into a larger cluster, because it actually directly, uh, violates the desirable conditions of the cluster. But there are a lot of algorithms which differs in how do you once you make the decision, right? And how do you measure the similarity between Ci and Cj, where Cj is actually merged from, let's say, two clusters. Or in general, I mean, you don't really care how they are merged. All you need to care is that you actually have Ci and you have Cj, and each of them actually have a bunch of points. Right? And last time we actually give you both um, graphic illustration and also reasoning on there are several different choices. You can be optimistic, thus allowing clusters like this shape, for example, right? So if you have this kind of lie down shape cluster, this is C1 and C2, if you use the single link algorithm, basically they are more optimistic. So if we zoom in, um, the smallest distance is actually this guy and this guy, right? So that's the distance, and that distance uh, is not too bad, okay? But if you think about the max algorithm or the complete link, they actually look for the worst case. The worst case is something like these two, right? So it's the distance between these two guys. So you can see that if I measure C1 and C2 by this measure D1 versus, I mean, D1, then they are likely to be, because the value is small, so they are likely to be chosen in the next round to do the merge. But if you choose D2, where the algorithm is more pessimistic, basically the value will be large, and um, it's more likely that these two will actually be merged at the very late stage. Okay, so um, here we actually look at essentially what we do. So this is an example of the single link where we start with 5 by 5 matrix, and our idea is trying to gradually reduce it to be 4 by 4, and then to 3 by 3, and then from 4 by 4 to 3 by 3. Uh, there's something wrong with what's going on. Okay, I guess I need to pause the video for a minute.